Welcome to Easy Physics. In this lesson, we are going to look at Lensmaker's equation. Think of a lens. It has a surface, curved surface, and another curved surface. Different radius of curvatures, R1 and R2. What will be the focal length of such a lens? The focal length of such a lens is calculated by this formula. 1 over f is equal to n minus n0 divided by n0 times 1 over r1 minus 1 over r2. So in this formula, what is f? F is the focal length of the lens, and n is the index of refraction of the lens material, and n0 is the index of refraction of the surrounding medium. If this lens is in air, instead of n0 we are going to write index of refraction of air, which is 1. If it is in water, for example, this lens, then instead of n0 we are going to write index of refraction of water. R1 and R2 are the radius of curvatures. If the lens is in air and n0 is equal to 1, then this equation reduces to this one. It is much more simple. Then what is the sign for R1 and R2? When the surface is convex toward the object, R will be positive. When the surface is concave toward the object, R will be negative. When the surface is a plane surface, it is smooth, in this case R will be equal to infinity. In this case, for example, this is the front surface of the lens and it is convex toward the object, it will be positive. And the rear surface of the lens is concave toward the object, in this case it is going to be negative. Let's solve some examples. Assume we have a biconvex lens in air, radius of curvatures are equal to each other, and we are asked to find the radius of the curvature. It is they both are equal to r, and it is equal to what? If focal length is given as 20 centimeters. Let's use our formula. 1 over f equals n minus 1 over r1 minus 1 over r2. Since it is in air, we use this formula. 1 over 20 equals index of refraction is 1.5 minus 1 over, what is R1? R1 is this surface. It is the front surface, and as you see, this is R1. It is convex toward the object. It will be a positive R. Minus, this minus comes from the formula, 1 over R2. This is the rear surface and its radius of curvature, this one, and as you see it is concave toward the object. It will be negative R. So from here, 1 over 20 will be equal to 0.5 times, this is minus times minus is positive, it is going to be 2 over r. And after doing some calculations, r going to be equal to 20 centimeters. Let's look at another example. In this example, we are asked to find the radius of curvature. This side has a radius of curvature r, and this side is a plane. The index of refraction of the material is given 1.6, and the focal length is given negative 10 centimeters. Let's use our formula. 1 over f is equal to n minus 1 times 1 over r1 minus 1 over r2. The system is in air. Negative 1 over 10, focal length is given as 10, equals index of refraction is 1.6 minus 1 over, now as you see here, we are asked to find this r, and it is concave toward the object. It is a negative r, but if you write negative here at the end, you are going to find a positive value. So in mirror and in lens equations, if you are asked to find a variable, initially do not put its sign. In this case, we are not going to put its sign, and we should find a negative value for this r because it is concave toward the object. Minus 1 over infinity, since this surface is a plane surface. So from here, my negative 1 over 10 will be equal to 0.6 and 1 over r. From here, r will be equal to, multiplying these two will give us a negative 6 centimeters. So as expected, radius of curvature, the value for the radius of curvature is negative. Let's go to the next example. So in this example, we are given a lens. It has 2 radius of curvatures like this, and index of refraction is 1.5. We are asked to find the focal point for this lens. So Let's write this is again in air. We are going to write 1 over f is equal to n minus 1 over r1 minus 1 over r2. Okay, 1 over f equals, index of refraction is 1.5 minus 1, and we are asked to find f. We need to write the sign for the radiuses. R1 is, as you see, the front surface of the mirror is concave toward the object. It will be negative 12. Minus from the formula 1 over the second surface is convex toward the object, as you see, so it is a positive value, 16. Okay, so after doing some calculations, I'm not going to go into the details of the calculation for saving the time. We are going to see that f is going to be equal to negative 13.7 centimeters. So let's look at one more example. In this case, we have a biconvex lens, two different radius of curvatures, and index of refraction is 1.52. And let's start with A. Find f in air. 1 over f, I'm not going to write the formula once more. 1 over f is going to be equal to 1.52 minus 1 over, let's look at this surface. It is a convex surface toward the object. That's why its radius of curvature, as you see, is 15 centimeters. We will write 15 positive. Negative, this comes from the formula, divided by the second surface. The rear surface of the lens is concave toward the object, and it will be a negative 20. So after doing some calculations, I'm not going to again go into the details, and f will be equal to approximately 17 centimeters. What if the lens, the system is in air? What will be its focal length? Now in this case, we are going to write this formula. We are going to use this formula. 1 over f is going to be equal to n minus n0 divided by n0. n0 is the index of refraction of the surrounding, times 1 over r1 minus 1 over r2. So from here, this is going to be equal to, let me write 1 over f equals, n of the glass is 1.52 minus 1.33, index of refraction of water, divided by 1.33, times 1 over, it is same as here, 1 over 15 minus 1 over minus 20. So after making some calculations, the focal length is going to be equal to approximately 67 centimeters. Okay, the next question, does it matter which lens face is turned toward the light? If, for example, we put the object to this side, and if we put the object this side and we look from this side, what will change? What do you think? The focal length is going to be, for example, smaller, bigger, negative, positive again, or something else? In this case, nothing changes. Again, the focal length will be the same. Now, if you want, we can do a calculation if we are looking from this side and object is at this side. Let's do it, for example, when it is in the air. 1 over f equals, index of refraction of the material is 1.52 minus 1. And now the object is here. This is the front surface. It is convex toward the object, that's why it will be a positive, and this radius of the curvature is convex and its value is 20, minus, this is from the formula, 1 over the back surface. Now the object is here and this is going to be the back surface, and its radius of curvature is 15 centimeters, but it is concave toward the object is here, that's why we are going to write negative 15. So as you see, this negative makes positive. It is similar here, negative it makes positive. Everything is the same. Again, you are going to calculate f to be 15 centimeters again, approximately. Okay, thank you for listening.